Hello. A lot of questions, and some of the basic questions I get is what is the difference between a technician and associate engineer and engineer? Because it is confusing as these terms are used in other references as well. So, uh, when I was learning, I was trying to find out the differences, but I couldn't get a clear picture from anywhere. So, I thought I'd make a quick video and show it to people what basically the differences are. Let's say we have three stages in this whole setup. At the first we have a technician, second we have an associate engineer, and third we have an engineer. Now let's take this remote for an example. Okay, a technician might know that this button is supposed to be placed here, this button is supposed to be placed here, and this button is supposed to be placed here. This goes here and this goes here. But he might not know the understanding of how it actually works. He might know or she might know what goes where, but they might even know how it is connected, but they might not understand the why of it. They just know it's there and this is the way it's supposed to be done. Now the associate engineer or the engineer will first explain it to them like these groups of buttons you will place over here, and these groups of buttons you will place over here, and you will close it like this and you will screw it like that, and then it's done. Okay, so that is what a technician basically does. Now you come to the part of an associate engineer. Sometimes a junior engineer is also called an associate engineer, but I'm not talking in terms of titles, I'm talking in terms of fields. So when you come to the level of a associate engineer, the associate engineer will know and should know what these buttons are there for, what are their functions, how are they connected, and the PCB inside where they are connected to, how is that working, and the overall operation of this remote, A to Z. The cells, the buttons, which buttons do what, where, and the whole internal structure, the logic behind the remote, the brains behind the remote. He will understand that, or she will understand that. If you ask an associate engineer to make you a remote from scratch, most probably they can. If it is a normal, let's say a standard technology where nothing new is required as such. So they will even be able to make you something from scratch, provided it is something which already has been developed and already there are standards for it and procedures for it. Now the rest goes on to the capability of the associate engineer. Now when you come to the engineer, what is the difference between an engineer and an associate engineer and a technician? Is that an engineer will know about this remote in depth. Now how can I explain in depth to you? So let's first look at what Google says, what is a technician and what is an engineer, and then I'll explain it to you via a real life PCB and as an electronics, the difference between an engineer and an associate engineer, because it's a little hard to explain otherwise. Now the one thing you need to understand is that there is no hardcore lining for this, that this is that and this is that. There are gray areas, but you just need to have an understanding of who does what. So now I believe you understand what a technician is. Now, regardless of which field you go into, whether it's civil engineering, whether it's electronics, electrical, mechanical, the principles more or less stay the same. Now, if we come to the definition of a technician in broad, let me get that back. Broader. It is an expert in the application of a science or a person skilled in the technique of an art or craft. So what is the technique? That this button is supposed to go like this, in this fashion. A new person might not even know how to place the button and where to place the button, but the technician will know. Okay? So Then we go further down, an engineer. Now, the definition of that is a person who designs, builds, or maintains machines, engines, or whatsoever, aircrafts. So, this person is now the engineer, is from scratch designing and creating something which never existed before. The standards might exist for that, but the whole thing itself does not exist. For example, when you have an i3, then you had an i5, then you had an i7, as in computers. So i3 was a specific design. The motherboard was designed according to it, the components were placed according to it. So an engineer designed the i3. Then when you went to i5, then again everything had to be redesigned according to the i5. Then you went to i7, then everything again had to be designed from scratch for the i7. So this is where the engineering part comes in. Research, development, in-depth knowledge about what goes where and how. So if I give an example to you via PCB, this is a normal PCB that you can see on the screen. It's an electronic circuit, something like which is inside this remote as well, but not like this, definitely different. But let's see how this is and how this works. So you see all these different components here. Now let's say if I have the RAS, you see this component is different from this component is different from this component is different from this component. And if I go in, you see, let me just do this. You see this component, this is a diode. Now, why is this specific item placed here? See, that is what the engineer and the associate engineer does. If I go into another, let's say components, let me take this. Where has that gone? Here, just okay. Take these. Oh, okay, that's wrong. The solid color. Remove that. Shapes, fill, no fill. Okay, that's good. Okay, now if we take these components, or if we take these components, now each component has, each one of these things have a specific design. They are made up of specific materials. They have specific tendencies. They have specific heat limits that they can operate on. They have specific functions that they can do this, they can do that. It's more like a Lego, blocks of Legos. So unless you know which component does what, you will not be able to make a PCB. Now, the engineer and the associate engineer know this, that this is the component, or they find out that this is the component, this is what they do. Then why the mathematics is so heavy in engineering is because they have to calculate each and every component's structure, weight, heat tolerance. For example, if they put the wrong component there, it's going to keep shorting out again and again after a certain use, and then the device in the end, you will say it doesn't work, it blows out after every such time. So that's bad engineering. It stops working, you get it repaired, it stops working, you get it repaired, it stops working. So why? Because it was not engineered properly according to how it should have been. Now there are hundreds of components. Now there are various ways of doing things. There are different types of packages. In electronics, packages means a resistor, if you might have heard, or let me explain to you this way. This is an IC and this is also an IC. Both of these are ICs. This is an IC and this is an IC. But if you see the feet of these, see how the feet are different? These. And if you take this IC, you see how these feet are different? So these are called packages. Both are ICs, but both are in different packages. Now, it is the choice of the engineer to use what and where. It is up to his or her knowledge, her studies, her skill, and then they come up, and in the end, they create something and say, okay, this is it. So the bottom line is, If you ask an associate engineer to make an i3 for you, or an i7 for you, the motherboard and the whole PCB like this, an associate engineer will probably not be able to do it, because that is not within the technical skills of an associate engineer. An associate engineer can repair it. Yes, he and she will definitely be able to find out what is wrong. If something goes wrong, they can copy it. Definitely, they know what works where, and if something is shorting out again and again, they might be even able to upgrade it or change it, so it does not keep shorting out again and again. A technician cannot do that. So, in conclusion, what an engineer does is he or she starts from scratch, makes something. Okay? Starting from scratch. Okay, out. That's loud. Sorry. Okay. Levy? No. Okay, sorry. Then the associate engineer handles it, maintains it, runs it. The technician is the guy or the person you see usually at repair shops, or they might not know how this specific component works, how this specific component is made, what is the heat tolerance. They might just know how to connect it. They can copy it, but they might not know the internal structure or workings of it. Or if something serious goes wrong in it, they might not be able to fault find. So, in a nutshell, this is what the difference is between a technician, between an associate engineer, and an engineer. So, for a recap, the engineer starts from scratch and makes something which was never there before. He can or she can do that because of their knowledge, and that's why they need a surplus of mathematics, because they need to figure out how to arrange these components, what happens when you do this, what happens when you do that, and how to calculate that mathematically, the interaction between those components, the effects of one component on the other component, okay, so forth. The associate engineer might not be and is not so well versed in the mathematics of it. He is more or she is more versed in the functionality of it, how it works, and fixing it and creating it and so forth, like I said before. And about the technician, I said that to you earlier as well. So that's just about it. That is the difference between a technician, an associate engineer, and an engineer. Now, job titles are different. Some companies call engineers associate engineers because they are new. Job titles is completely something else. But I'm talking in the specific relative terms to what is a technician, what is an associate engineer, and what is an engineer. So if you're planning to do either of the three, you know exactly what you're getting into. An engineer, a lot of mathematics, a lot of in-depth studies about how, what, when, and why. Okay, a lot. You might not even be using them or that knowledge if you're not into R&D. If you don't go into a company which is regularly creating something like Texas Instruments, like Intel, like IBM. So most of those skills are going to go to use, not going to be utilized unless you go into R&D and specific manufacturing concerns like that. Then associate engineer, la la la, and technician, da da da. So that's just about it. You know everything. That's it. And if you have any suggestions and if you think I'm wrong, please do let me know. And that's it. Thanks. Bye bye.